Am I good now?
Yep, go ahead.
Hi, everyone. Welcome to my presentation. I would be presenting kind of a broad overview of how data science can be used in a particular cybersecurity attack, but in general, talk about cybersecurity and how data is kind of fundamental, can be fundamental in figuring out and in detections and eventually prevention as well. My name is Dibya Mukhopadhyay. I'm a principal data scientist at Zuora currently. And before my job at Zuora, I have worked at multiple other companies as a data scientist and an engineer, like Workday, Google, Visa, etc. And I'm very happy to be presenting to you. All right. So in the modern day, we have really a lot of pain points with cybersecurity threats with every day, and they're growing, right? First of all, one of them being data breaches. We all like to online shop, and if your favorite retailer's account gets hacked or their database gets breached, your username, your email address, and your password, if they're not encrypted, are up for the grabs, right? And then say phishing. If I'm sure a lot of you, everyone must have gotten it here. When you get a random email address with a link that looks like your bank account or looks like your, I don't know, Amazon account, and they ask you to verify your credentials or something has gone wrong and you have to do this. But they're not quite right. There must be a grammatical mistake or something, and those are phishing links. And once you click that, the attacker either can steal your credentials or install something in your laptop or computer that can eventually steal your stuff, steal your information, or install a malware. And on that one, we already have the next one, malware. So malwares are also separate softwares or files or they can be viruses as well that get installed to your system. And once it does, it corrupts your system. They can take um, entire control of your system, steal your data, and so on. And ransomware is a specific type of malware where the attacker gains control of your system, encrypts your data, and holds the person hostage for money or for something else until they pay that, their data or the device is not handed back to them. So what is account takeover? Account takeover essentially is kind of done by using all of these um, kind of cybersecurity attacks that we spoke about before. So say you get a phishing link on your email for your bank account and you click it, right? And then through social engineering, they would ask you a few questions. Hey, so this has been happening. We are going through an overhaul of your system, and you need to log in again just so that we can update your information in our system and your account access is restored. And you enter it, and they get your credentials. Or say using data breach data from your favorite online retailer. We all like to shop online, right? They would use that information, the credentials, and kind of brute force it for every account. And if you happen to reuse your passwords in other accounts, they can get access to your other accounts, more sensitive accounts, say, and take control of that. And once they have that, they normally use bots to systematically brute force across a lot of different websites, say Chase or Fidelity or so 401k or banks or online retailers, credit cards. They would just go across them to figure out if they can log into anything, right? That is account takeover attack. And why is it important? Well, today, whatever you can do online requires mostly an account creation. Now, a lot of the accounts are not that important, but we do have different passwords that we reuse across accounts so that it's simpler for us to remember. Or, like say an e-commerce website where you shop a lot. You might have your credit card information saved there, or they can make a purchase for you and then have it shipped to their address. And before you can catch it, it might be too late. Second thing can be banking. If they get access to your banking account, that can be a disaster, right? They can write themselves a check, they can transfer amount from your bank to their bank accounts, and so on. Or credit card accounts, for that matter. All the credit cards, physical credit cards, have the year, month, and the security code. They can do a lot of damage using, say, credit card points, or even the credit card just by the credit card number by itself as well. Next comes airline or travels. Say you are an avid traveler and you have a lot of Hilton points, right? So they can just log into your account and book themselves a great vacation at the cost of all your hard-earned points, which can be pretty damaging financially if you think about it. Or another example is something like a salary account. We have Workday, ADP, etc. in our workplaces today that we use for accessing our pay stubs, for checking. Some of them are also, like for Workday, for instance, also has, you can check your like org charts, you can check your benefits, you can check your pay stubs, you can manage your insurance and all of that. What if they get access to that, download your pay stubs, or change the banking account for your pay stubs so that the next salary you get doesn't go to your bank account, goes to some other bank account, right? That can be disastrous. And then social media. So a lot of our lives is on social media today. And apart from the fact that your data would be breached, your privacy and all would be breached, your friends and your near ones are the risk of harassment and extortion. And not to mention, social media today is also the platform for shopping, online shopping, and so on. So they can also misuse that platform, like the e-commerce platform, to buy something or cause you monetary harm. So essentially, anywhere that you can have an online account, ATO is important for that. ATO attack is pretty important for that. So this use case kind of came up when I was working in Workday. So my conversation or the presentation from this slide onwards would be more kind of focused towards salary accounts or Workday account, where we have pay stubs, benefits, etc., like org charts for other employees in the in my company and so on. So what kind of data signals we can use to figure out that if that account is hacked, but nothing bad has happened yet, but it has been hacked, and if we can kind of send an alert to the person saying that, hey, your account seems like it has been hacked, so you might want to change your password and make sure that your bank account information is all the same and everything is correct. So first one comes at first set of data that we can look at is suspicious login activities. Say a person logs in from a device that is not known, say a new laptop, a new different mobile device, or a different tablet that has never been used, and different time of the day. Say you are located in the Pacific coast, but the login happens somewhere in, I don't know, Africa. You must be sleeping at that point in time, but someone is logging in and checking the org, checking your pay stubs or something at that hour of the day, which is not normal. Then there can be session anomalies, like someone can be using an absolutely different browser that you don't use. Maybe you use Chrome and they're using Firefox or Safari or something else that is not at all in your radar to use ever. And then we also have browser IDs every time someone logs in to any of these systems. Workday system had it. So what if your browser ID is completely different? Browser IDs do not normally change unless you refresh everything and remove everything, remove all the history and cache and everything. Browser IDs do not change. So browser IDs being different can also be a trigger point. Then there are location anomalies. Say, for instance, like I said, you are in Pacific, you are in the Pacific coast, and someone logs in, one from Africa, and then in 20 minutes from somewhere in Europe, and then in another 1 hour somewhere in Asia. So you cannot possibly be traveling that fast. And from the data that we saw, there were some weird trends that came up, although they are very rare because the attackers are also smart to not do that, to trigger an alert. But there are things like that that would come up that can trigger such a such an anomaly. And then finally, data download. Like, what if someone is bulk downloading your payslips, going back and checking what you have been paid for, like the last 6 months and 7 months and 8 months? Like, you might need payslips at any given point in time for, I don't know, showing your employment history and so on, but not to that extent, and not to mention with all the other attributes in conjunction, like a different time of the day, or from a different location. And finally, this is the worst thing that can happen. Hopefully, we can stop before that. Is they have updated your bank account information. A person, an employee, normally doesn't really update their bank account information multiple times during their year. And I mean, for me personally, I just update it once when I join, and that's it. It stays the same. And I think that's the same for most of the people. And if that is getting updated every now and then that's a very suspicious thing to have happened, right? So these are some of the useful data feature signals that we can get features from to use in our prediction. Now, I've been talking about predictions a lot, but why machine learning? We can use a basic rules engine to do this too, right? Why machine learning? Because the attackers are becoming smarter and they're choosing different attack techniques. And in a matter of not even months, I have written months here, but just in a matter of a week or so, they change their patterns. And with every day, new software, new technology coming out, they are using ways so that they cannot be detected with IP spoofing and you know copying browser data and everything. You might not be able to even track them through those um, data signals. So if we have a rules engine in place that kind of has like, okay, if the login is from Nigeria, but you are from here, then block these IPs and do not let these things log into your account. They might as well change it the next day if they get a hint of it that they're getting blocked like that. They can they can have a different IP address. People can buy now IP addresses very cheap, like IP address blocks very cheap when they're trying to hack someone. So that's the reason a stagnant, like a specific rules engine would not work. Something that is constantly evolving and we're retraining the system to fit the current attack kind of scenario, that would be more helpful. So a machine learning model is more apt than a rules engine in this situation. And so while we're talking about machine learning here, there is a problem though, because like fraud, this use case also has a huge problem that mostly, I mean, these kind of situations hopefully does not happen a lot, right? Maybe 1% of the cases would be account takeover attacks. Like there won't be 30% of the cases where an account gets taken over. I mean, fortunately so, which is good thing and but bad thing in this situation because we don't have too much data. So the problem itself is very imbalanced. So when we try to use machine learning for solving this problem, there's a data imbalance that's there with the two classes. The class that is like the benign class and the fraudulent class. The fraudulent number of samples are very low to learn from. So there are a few techniques that we can use. We can either undersample the majority of the data set, majority class rows, and then oversample the minority class. But then with undersampling and oversampling, what can happen is either you overfit with oversampling, or with undersampling, you might lose some of the very important patterns in the data that could have been very useful. So you don't know this because you're randomly undersampling and randomly oversampling. A bit better technique compared to that is SMOT, because that is synthetically generated. So we synthetically figure out some of the minority points or data points, and we figure out k nearest neighbors to that, and kind of fill in the gap in between the neighbors and the minority points, so that they are not getting repeated data points, but new data points that are synthetic, so it will not overfit the model. But the one that is a winner is XGBoost model. In this case, XGBoost is a type of gradient boosted tree modeling, which helps with class imbalance a lot, where you build multiple small trees for your with different with different features rearranged in different levels, and then you take an ensemble of them to make your final decision, depending on depending on the learning, the how good or bad the model is performing in terms of the label data set. And XGBoost models have always been known to handle class imbalance on their own. So, and if you can tune some of the hyperparameters, like number of trees you're using, maximum depth of the trees, they can give you very good performance. In our case, we got something close to like 70% or 80% accuracy, which is pretty, which might not sound very good in this situation, but was pretty good in our situation, because if we can prepone and like handle the situation preemptively and let them know that something can happen to your accounts, to our clients or customers, that was a win for us. So in conclusion, ATO attacks can be significantly damaging for all of us who have online accounts today. Attackers are getting smarter, so we need ML or AI-based solutions. And as a future work, I think deep learning or predicting for fraudulent user activity patterns can, curb sophisticated attacks, where we can look at an user activity history and kind of predict the forecast or predict the pattern of it in future, which would need like a temporal component to it too, to looking at the user activity, how it has changed over time, how it has updated over time, and what it can do given that in future. And that concludes my presentation. So if you have any questions at this point, let me know. Let me see if I have any. Oh, there's one question. When you treat imbalance issue, do you only use a training data set? Thanks for the great talk. Yeah, we normally use a training data set. So we can do, when we are using the data set, we can do k-fold cross-validation. That's something we can use. And but we are using essentially the points in the data set to either oversample the minority class or undersample the majority class, or use something like SMOT that is a bit better than either of the random undersampling or oversampling methods. Any other question? All right. Thank you so much. I really appreciate your time. Hope you have a great rest of the day and you enjoy your sessions. Thank you. Oh, there's another question. Okay. What are some of the hyperparameters you have found useful in the imbalance data sets? Yeah, so sometimes going, depending on the features that we have, right? If we go too deep into the tree, sometimes that can be adversely effective to the model. So we curb the max depth of the tree sometimes, or the number of trees that has been there. There's also another hyperparameter called gamma that helps with the performance as well. Good question. Thank you. Any other question?